Mom. It says factor the following. Well, the first step in factoring is the GCF, you guys said. Number one is 1, 2, 3, a trinomial. There's no GCF, and there's a number 2 in front. I know that this is going to be AM, but since I have a number 2 in the front, I have to multiply it with my C number, right? So let's see. That changes my M number to 42. And what's my A number? 17. So two numbers that multiply to give me 42, but adds to give me 17. What? 3 times 14. Super.
Neither of them are negative.
Great. Good job. 3 times 14, which gives me 17. Okay? So remember, whenever you do this, swing it over, you have to bring down the first, bring down the last, and you're going to rewrite this 17x using these two numbers that you have, right? Yeah. Okay, so positive 3x and a positive 14x, right? So now you have 1, 2, 3, 4 terms. How do you factor with 4 terms? Split it. Divide it in half. You need to find the GCF. Yep, find the GCF for both sides. Run out of room here. 14x plus 21.
7.
7. How do I know that I did this right? The parentheses match. And then you just have to, sorry, I'm going to write it over here. Double parentheses. Then 2x plus 3, and then x plus 7. All right. Good. That's it. Perfect. And you know what? If I wanted to check this, because when you have a is greater than 1, I mean, you just want to make sure that you did factor this right? Then, I mean, you could just do 2x times 2x squared plus 14x, double distribute, plus 3x plus 21, combine these, 2x squared plus 17x plus 21. Does this match this? Yes. So I did this right. Okay? So like on a test, I may, you know, FOIL double distribute it just to make sure that I got it right. On a homework, I mean, I wouldn't do it for all the problems, right? But maybe on the test. Okay, so number 2 then. This one's a little bit easier. R squared minus 16R plus 63. This is AM. I don't have a number in front, right? It's just 1. So T-chart. 2 numbers that multiply to give me a positive 63, but adds to give me negative 16. Negative 7 and negative 9.
It doesn't matter what order it's in, right?
Doesn't matter.
Okay.
So this one, you could do the same thing. You could do bring down the first, bring down the last, rewrite the negative 16R using your 2 numbers. But since this was just a plain old R squared, you can go straight into the double parentheses, R what? Minus 7, R minus 9. There you go. And that's it. Done. Okay? Questions about this? All right? Okay. All right. So I know that this is going to be the SOAP way because 2 things. Binomial, 2 terms. And if I look at this, x cubed, that's usually a huge hint. Multiples of 3, right? So I'm going to look at 8 and 729 and think, okay, do they have a GCF? No, it's 1. Are they perfect cubes? Right? 8 cube root of 8x cubed, well then that's 2x. Right? And then this guy, cube root of 729, that's what?
9.
9. So, okay, perfect. Binomial, perfect cubes. Now I can start my SOAP setup, right? So this one has 2, this one has 3. You just found the two terms that go in your 2, your binomial, your first parentheses. You have 2x, which came from 8x cubed. You have the 9, which came from the 729. I'm going to save the signs for when I do the SOAP, okay? So in the first one is your first term squared. That means 2x times 2x, which is what?
4x squared.
Good. And then the one in the middle, you multiply these two. So what's 2x times 9?
18x.
18x. And then the last one is your last one squared, which is what?
81.
81.
Okay,
9 times 9, right? And then now this is the fun part. So same as the sign. Opposite, always plus. Okay? All right, good. So number 9 is, okay, well this is a dose, well possibly a dose. The reason why I went straight to dose is because I have 2 terms, so this is a binomial. And if I look at this x, it has x squared, right? And I don't have a GCF. 25, 49, GCF is 1. So since that x has a 2, I go, okay, well maybe this is a difference of squares. Is it subtract? Yeah, so I can do difference of squares. Square root of 25 is 5. What's the square root of x squared? What's the square root of 49?
7.
Perfect. So this is a dose. Double parentheses, opposite signs, and then square root. And we already did it right there. 5x plus 7, 5x minus 7. There we go. Okay. All right, so number 12. Okay, first step in factoring is GCF. So if I look at this, x cubed minus 64x, what do they both have?
X.
They both have x. This one has x cubed, this one has a plain old x. Which x comes out?
No.
Well, the x comes out because it has a smaller exponent, right? Okay, so then I open parentheses. I have to divide everybody by x. And then I have x squared minus 64. So whenever you guys do the GCF, you can't just stop and say, okay, I'm done. You need to check inside the parentheses and make sure that this is done factoring too, right? But if I look at this, x squared minus 64, okay, I'm doing the same thing in my head again, saying x squared, so maybe this is a dose. Is subtract, so I'm getting closer. Is 64 a perfect square?
Yeah.
Yeah. So this is definitely a dose. I have to keep going. So double parentheses, opposite signs. What's the square root of x squared? X. What's the square root of 64? 8. Don't forget to bring down GCF. Okay? Alright. So what looked like it should be maybe a SOAP because it looked like x cubed. When we took the GCF out, it turned out to be an x squared, and then it was a dose, right?
Mm-hmm.
So number 17, first step in factoring is find the GCF. So I'm going to start with just the numbers. 3, 21, 30. Okay, 3, 21, 30, what's my GCF?
3.
3. Do they all have an x?
No.
No, so the only thing I can bring out is a 3. All right. Divide everybody by 3. And then I'm left with this. Yes? Okay. So remember, your GCF is not going to do anything, but inside the parentheses, you need to see if you could do more. 1, 2, 3. Trinomial?
5
Yeah,
times 2.
Let's see if we can do a T-chart. Because, you know, sometimes with trinomials, you can't do a T-chart, and then you just have to stop there. But let's see if we can find the numbers. Multiplies to give me a positive 10. Adds to give me a negative 7. Yes, Mary?
Negative 2 times negative 5.
Negative 2 and negative 5. Don't forget, when it's a positive, you could have two positive numbers, or you could have two negative numbers, because a negative times a negative also gives you a positive, okay? So then negative 2 times negative 5 is a negative 7. Since this was just an x squared here, you can go straight into your double parentheses, x what 2? And then x, and don't forget to bring down. Yeah? What was it? Was it something else on the answer sheet? Was it? Oh no. Oh no. What did it say?
X minus 2 and X
Minus 2, minus 5.
oh wait,
What did we have? Did we have the? Oh, you just read it wrong. Okay. No, it's okay. It's fine.
Yeah, you clarified it for me
Listen,
though.
you should ask. Okay. So number 19. 1, 2, 3, 4 terms. I need to see if they have a GCF for the whole thing. 6, 4, 27, 18.
27 is 9, 18 is 9. The rest
But not
is
for the whole thing, right?
Yeah.
So we're going to divide it in half. Okay.
2.
Find the GCF at the left-hand side. 2x squared. So divide everything on the left by 2x squared, and you get 3x minus 2. On the right-hand side, 27 and 18.
9.
9. So 3x minus 2. There we go. These match the parentheses, so it's 3x minus 2, 2x squared plus 9. Okay?
Yay.
All right. Now, number 22. Starting with a negative. Guys, anytime it starts with a negative, you need to bring that negative out. Divide everyone by negative. You get x squared plus 3x minus 18. And then you need to do AM. Two numbers that multiply to give you negative 18 and adds to give you a positive 3. Good. 6 and negative 3. Since this is just a plain old x squared, you can go straight into x plus 6, x minus 3. Don't forget to bring out your negative. You can put just a negative, or you can put negative 1. Okay? Yeah. And perfect. So now it's time for lunch. And when you guys come back, we will do this lesson. All right, so let's review factoring. We're going to start this lesson on solving by factoring. All right, so GCF is the first method. 2x squared plus 8x. What's my GCF? 2x. Okay, so, I mean, this is basically what we just did in the homework, right? X plus 4. Yes? Okay. So let's go on to difference of squares. X squared minus 9. How do we do that? Double parentheses, opposite sign, square root. X plus what?
X plus 3.
And x minus 3. Okay, so let's look at the trinomial problems. The first one is just a equals 1, right? It's just a plain old x squared. So we have AM, two numbers that multiply to give me a positive 36 and adds to give me a negative 12. What are they? Good. Negative 6 and negative 6. Since this is just a plain old x squared, I can go straight into my double parentheses, right? X minus 6 and x minus 6, right? All right. So how about this 9x squared plus 12x plus 4? Well, there's no GCF. Well, GCF is 1, right? But good, you're right. What were you saying? What did you say? You got to multiply it with the C, right? It's still a trinomial, so you still have AM, but when you have a number in front, you have to multiply it to get like a new n number, right? What's 9 times a positive 4? Huh?
36.
6. Positive 36. And adds to give me what? What's still my a number? 12.
So now it's just
Oh,
6
so
and
look at
6.
that. Two numbers that multiply to give me a positive 36, but adds to give me 12. 6 and 6. So remember, whenever you do this, you have to bring down the first, bring down the last, and then rewrite the one in the middle, the 12x, using the two numbers that you found. So plus 6x plus 6x. Okay, so now you have 1, 2, 3, 4 terms. So I'm going to divide it in half. Because anytime you have 4 terms, you need to group it, right? Find the GCF on the left-hand side. 9x squared plus 6x. What's that GCF? 3x. Divide by 3x. Divide by 3x. Okay? 3x plus 2. So how about 6x plus 4? What's my GCF there? 2. Good. So 2, and then divide each of those by 2. And then great, 3x plus 2.
Can you put a comma to a positive?
Huh? Can you put a what?
Another.
Yeah. Okay, I'll show that. So you have 3x plus 2 times 3x plus 2. Or, guys, you can also write this as 3x plus 2 squared, because it's the same exact thing, right? Good. All right, so that was just a little review on the factoring. So here's a little, okay, so when you're solving, you need to set the entire equation equal to 0. Okay? Everything has to be equal to 0. And then we factor. And then we need to set each factor, each of the parentheses and any GCFs that we might have, you need to set each of those equal to 0. And then we solve. So we only solve when we see an equal sign because those are equations, right? So if we look at example 1, it says 12x squared minus 5x equals 0. Okay, already equal to 0, so let's factor. So first step in factoring is the GCF. 12x squared minus 5x. What's the GCF here? X. Okay, so listen, this isn't anything different. We're still just factoring. Okay. So then we have 12x minus 5. And remember, all of it equal to 0. Right? Now, we're done factoring, right? Because can you, like, dose this inside the parentheses, soap it? No, right? So you're done. So now, you need to set every single factor equal to 0. So I like to call these like little mini equations, basically. This x that's out here, that gets set equal to 0. Okay? And then this 12x minus 5, that gets set equal to 0. And then we just solve for x. Okay? This one, x equals 0. I mean, that's already done, right? So perfect. Okay? This one, I need to add the 5. 12x equals 5. Now what? 5 by 12, bless you. And then x equals 5 12ths. Yes? All right. Here's the thing though, guys. You should have the same number of solutions as your biggest exponent. In example 1, what is your biggest exponent?
2.
2. Okay, that means I should have 2 answers. Perfect, right? All right, let's look at example 2. Is it equal to 0? All right, 4x squared minus 25. GCF? No. But what do we like about this? It's dose. That x squared, the minus is 4 perfect square.
Yeah.
X squared is a perfect square. Is 25 a perfect square? Yes. So this is dose. So double parentheses, opposite signs. What goes in the first term?
2x.
2x. And what goes in the second term?
5.
5. Because those are the square roots, right? Equals 0. Okay, so now, since we're done factoring, mini equations, right?
Yeah.
2x plus 5 equals 0. 2x plus 5 equals 0. Right?
2x minus 5. Minus 5.
Oh, I'm sorry, minus 5 something. Excuse me. 2x minus 5. Okay, now let's solve. Yes? And then over here, at the 5, 2x equals 5, divided by 2, x equals 5 halves, right? And you know what, before you guys turn the page, hold on, you know what I want to do, actually, now that I think about it? These are my answers, but can we start getting into the habit of putting them into solution sets, right? Okay? So in the solution sets, we always want to put it in order from least to greatest, okay? I mean, we're not going to mark it wrong if you don't, but technically you should. And since this one is actually, they're both 5 halves, one is positive and one is negative, you could write this like that, plus or minus 5 halves, okay? Let's just get used to seeing this, because you're going to see that a lot, all right? You could write it like this, or you could just put them separately. Negative 5 halves, comma, 5 halves. All right? All you're doing is you're just putting it in a solution set. The curly braces, 0, comma, 5, 12. All right?
Do they always have to equal 0 before we can do anything?
Yes.
No.
All right, let's look at example 3. Okay, so Mary said, does it always have to equal 0 before we do anything? Yes. So I need to take this 18, subtract it, move it to the other side. Now it's x squared plus 3x minus 18 equals 0. Is there a GCF?
No.
No. What kind of factoring method do I need to use? T-chart. A-M. Two numbers that multiply to give me negative 18 adds to give me 3.
6 and negative 3.
6 and negative 3. Good. Since this is just a plain old x squared, I can go straight into my double parentheses. X plus 6, x minus 3. Yes? Okay. Now what? So the whole thing's equal to 0. Mini equations? Yeah. So we have x plus 6 equals 0, and we have x minus 3 equals 0. So x equals what? Negative 6, and x equals 3. Okay? And then let's put them in the solution set. Negative 6 and 3.
Wait, how'd you go straight into it? Like, where's the right? Did you just take the 6 and negative 3 and put them with the x?
Yep. This is basically, guys, this is just saying it's a space to put your answers. Okay? It's a solution set. It's a little group of solutions. All right, so you guys try example 4, please. All right, so with this one, there's no GCF. This is just a trinomial. two numbers that multiply to give me a positive 18 and add to give me negative 11?
Negative 9, negative 2.
Negative 9 and negative 2. Since it's a plain old x squared, I can go straight into my double parentheses. X minus 9 and x minus 2, that equals 0. Now what, guys? Good. X minus 9 equals 0, and x minus 2 equals 0. So x equals 9, and x equals 2. Now I'm going to put them in my solution set. There we go. Yes? Okay. Try the next one.
Yeah, sure.
Wow, look at example 5. My goodness. So, we want to make it equal to 0. You know what? We'll just move these guys over. Since that's a negative x squared, we're going to add x squared. And since that's a negative 2x, I'm going to add 2x. Right? We'll just move them both in one sweep, right? So 0 equals, let's see, 2x squared plus 1x squared gives me, negative 12x plus 2x gives me negative 10x, right?
Oh, you're fine.
And then plus 8. That didn't get changed. All right? Equals 0. And then factor. So is my M number 8?
No, it's
Good. No, it's not, because you have this 3 in front. Now when you have a number in front of that x, you need to multiply it over. So 3 times a positive 8 gives me 24. My A number still stays the same though, right? Negative 10. So what are two numbers that multiply to give me 24 but adds to give me negative 10? Negative 6 and negative 4, because it has to add to give me negative. Alright, so then now we have, bring down the first, bring down the last, and rewrite the one in the middle, the negative 10x, using the two numbers that you have. The negative 6x minus 4x. I'm not going to put equal 0 yet, just because I have so many terms up there. I'm going to wait until I factor. Yeah.
I did negative 12 and 2.
Negative 12 and 2, but that multiplies to give you a negative 24. You want it to multiply to give you a positive 24.
What do you do negative 12 times?
Negative 12 times negative 2, but then if you add that, you get a negative 14, not negative 10.
Yeah.
Yeah, I know, that one's a little tricky, isn't it? Alright, divide it in half, GCF both sides. On the right hand side, remember your GCF is a negative 4 because it's starting with a negative. My parentheses match. So I have x minus 2 and 3x minus 4 equals 0. Okay? Now, same thing. Well, mini equations when you're done factoring. One extra sheet of paper. 3x minus 4 equals 0. Right? And then let's solve for x. So then this is x equals 2. This is x equals, did you get 4/3? add the 4, and then divide by 3. Okay. So in my solution set, I have 4/3. Yeah. Okay. You guys try number 6, please. Okay, so I'll do my work up here. Subtract the 6 to make it equal to 0. Now, this is AM because no GCF, but it's a trinomial, right? Have a number in front. Swing it over. Two numbers that multiply to give me negative 30 and add to give me 13. No, that's not going to work. Shoot. Well, you know what? Well, make a list. Negative 2 and 15. That's 1. Yes? Okay. Bring down the first. Bring down the last. Rewrite the one in the middle using the two numbers that you found. So here, guys, when you have your negative 2 and you have your 15, right? You could write those two numbers in any order. Some of you might want to put the 15 next to the 5 because you know you need to take the GCF. 5 and 15, that's a nice fit, than 5 and 2, right? Not that you have to, because maybe you don't like the negative being in the front, so then you're just going to put the negative 2x first so you don't have to deal with the negative. I don't know, okay? But I'm going to go with 15x. I'm going to put the negative 2 with the 6, okay? So then we have 5x that comes out on the left. Negative 2 comes out on the right. So do you have x plus 3 times 5x minus 2 equals 0? Okay. If you flipped your numbers and you said negative 2x plus 15x, then inside the parentheses you would have 5x minus 2. But either way, you should still get these same factors. Okay? Now we have our mini equations. So x plus 3 equals 0, and then 5x minus 2 equals 0. Right? And then when you solve, you should get x equals negative 3, and x equals 2/5. Okay? For number 7, guys, I would rewrite this, put it in standard form. That x squared has a negative in front of it, so this is actually negative x squared plus x plus 30 equals 0. What do I need to do? Get rid of the negative. You need to factor out the negative. Then you can AM factor inside the parentheses. This is a plain old x squared, so two numbers that multiply to give me negative 30 and adds to negative 1. What are they? Negative 6 and 5. You can go straight into your double parentheses because that was just a plain old x squared. So, all right, so double parentheses, x minus 6, x plus 5. Don't forget to bring down your GCF equal to 0. Are we all here? Do you need a few more seconds? So when you get here, all right, we have 3 mini equations, right? Because we also have a GCF on the outside. But this GCF, well, if you set this equal to 0, is that right? No, -1 does not equal 0, and there's nothing to solve because there's no x there, right? So this guy, just throw it away. Okay? As a number equal to a 0, I mean, unless it's 0 equal to, you know, no, throw it away, right? X minus 6 equals 0, so x equals what? And this one, x plus 5 equals 0, so x equals, thank you. So then in our solution set, we have x equals -5 and 6. Okay? All right, so let's try the next one together. If I want to make this equal to 0, what do I have to do? Thank you, Elise. 4x squared minus 9 equals 0. Guys, which factoring method do I have to use here? Thank you. So we have, what goes in the first term? 2x. Square root of 4x squared is 2x. What's the square root of 9? 3. So now you have 2x plus 3 and 2x minus 3, mini equations, and let's solve for x. Yes? And then in my solution set, you can write them out separately, but since it's the same number, and one's positive and one's negative, I'm going to put plus or minus 3 halves. Alright? Guys, I know that you're working on these practice problems. I don't know why you're packed up. We have 7 minutes. If you're packed up, you'll be the last ones to go. Get all your stuff out, okay? So, I'll put my work up here and we can compare. I saw that a bunch of you guys were working on this, so. So for this problem, since you have 2 answers that equal the same exact number, you just have to write it one time, okay? Example 10. Example 10 is a dose, right? Yes? Any questions? I should be checking your work, right? Okay. So the next 2. Alright, this one is AM, right? So this is the same situation. You have the same exact factors. So you have x equals -8 twice. Alright? This is a special case. It's called a double root, but we'll get to that later. So this is an AM, but it's the swing one. Thank you. Two numbers that multiply to give me the negative 60, add to give me 4. What do we have? 15x squared, 10 and negative 6. Yes? This one was a little bit more involved than the other ones. Mini equations. So we have 3x plus 2 equals 0. And we have 5x minus 2 equals 0. X equals negative 2/3. X equals 2/5. Okay? So remember, next class, you're factoring mini tests. We're going to have D lunch because we have a lesson after that test. Okay? Retakes for the Unit 1 test, please do that by October 20th, Thursday. And if you need to do corrections, if you need help on that, please come and see us. All right? Also, if you're planning on taking the retake, we have a form you need to fill out with your corrections. Okay? So please let us know if you need that form. All right?